All right, so we stopped after example 4, right? So looking at example 5, it says evaluate each expression without using a calculator. All right. So what we have to do when we do these is you have to look at the innermost thing first, right? And if it's looking for an inverse, what are we looking for? An angle. That's right. So thinking, first of all, tangent is going to be in quadrant 1, inverse tangent, right? It's either going to be in 1 or 4, but because it's positive, we know it's going to be in 1. Yes? All right. So tangent is opposite over adjacent. Yes? All right, and so this is angle theta, or whatever angle you want to call it, right? I'm going to call it theta. So at this point, then, all you're trying to do is find sine of angle theta. Do you agree? And sine is opposite over hypotenuse. So I need that hypotenuse there, don't I? Can I find the hypotenuse?
Yes.
Yeah, a squared plus b squared, right? Pythagorean theorem. So 3 squared plus 2 squared equals my hypotenuse squared. Agreed with that? All right, so 9 plus 4 equals h squared. That would be 13 equals h squared. So this would be the square root of 13. So sine of this is opposite over hypotenuse, or 3 over the square root of 13. But can we leave it like that? No, we need to rationalize, right? So I multiply by the square root of 13 over the square root of 13. And this would equal what? Yes. Not too bad? All right, so looking at this one. Here, this is an angle measure, yes? So we're looking for that angle measure there. So cosine is in quadrants 1 and 2, right? Inverse cosine. And it's negative, so it's got to be in quadrant 2. Cosine is adjacent over hypotenuse. All students, so we know tangent's going to be negative there, isn't it? You agree? All right, so I need the opposite side here, don't I? So my opposite side, y squared plus x squared equals the hypotenuse squared. So y squared plus 25 equals 169. And I subtract 25 to both sides. So y squared equals what? 144. Square root of that is 12. Do you agree? So tangent, we said in quadrant 2 is negative. Opposite over adjacent would be negative 12 over 5, yes? So this one we were looking for an angle. Outside we were looking for a value because it's not got the inverse, right? Everybody understand that? Okay. Looking at example 6, it says evaluate each expression without using a calculator. Well, this looks eerily like some cosine of, this is an angle, isn't it?
Yes.
And this is an angle. So 2 angles added together. So it looks like cosine of A plus B. Do you agree with that? What's our cosine sum rule?
Cosine A cosine B minus.
Yep, that's right. Cosine A times cosine B minus sine A times sine B. I agree. Well, let's talk about angle A first. Angle A is the arc tangent or inverse tangent, right? Of angle A. So tangent of angle A would equal what? Square root of 3 over 1? Is that fair to say? All right. So tangent is in quadrants 1 and 4. It's positive, so it's going to be in quadrant 1. opposite square root of 3, adjacent 1. And this is actually a special right triangle, isn't it?
Yes.
1 square root of 3 and 2. All right. And then for B, we're talking about sine of angle B is 1/3 essentially. So sine is going to be in quadrants 1 and 4 also. It's positive, so we're talking about quadrant 1 here. Sine is opposite over hypotenuse. Now, I need to have that missing side there, don't I? Yeah. So if I need that missing side, I'd have to do what? 1 squared plus x squared equals 3 squared? Everybody agree with that? 1 plus x squared equals 9. Subtract 1. X squared equals 8. When you take the square root of that, what do we get? 2 square roots of 2. All right, so when I expand this, I'm going to have cosine of arctan, and I'm going to use the abbreviation there, tangent -1 square root of 3, times cosine of b, which is inverse sine of 1/3, minus sine of a, which is that tangent inverse, and sine of b, which is inverse sine of 1/3. So cosine of angle A. Cosine is adjacent over hypotenuse. What would we get there? Cosine is adjacent over hypotenuse, so 1/2. Thank you. Cosine of the bottom one. Yep. Minus sine of the top one would be. Yep. And if you have sine of inverse sine, it's going to be whatever's there, right? I mean, you're taking sine of that same angle. All right, so here we have 2 square roots of 3 over 6 minus the square root of 3 over 6, which together would be 2 square roots of 3 minus the square root of 3 all over 6. 2 square roots of 2, that shouldn't be 3 there. As I say, we could combine that, but we can't because that should be 2. Sorry. Questions on that? All right, this one also looks like some double angle to me. So this is an angle measure, isn't it? So this looks like tangent of 2 times some angle measure A. Is that fair? If we call this angle A. So the double angle identity for that is 2 times tangent of A over 1 minus tangent squared of A. So sine, arc sine, is going to be in quadrants 1 or 4. It's positive, so it's going to be in 1. Sine is opposite over hypotenuse. And I'm going to need tangent, so I'm going to need the opposite and the adjacent. Do you agree? So I need this x value. So x squared plus 2 squared has to equal 5 squared. So x squared plus 4 equals 25. Subtract 4, x squared equals 21. When you take the square root, you get the square root of 21 down here. Everybody agree with that? All right, now we just substitute in 2 times tangent is opposite over adjacent. So 2 over the square root of 21 divided by 1 minus 2 over the square root of 21 squared. So in the numerator, I get 4 over the square root of 21. Down here I'd have 1 minus, what, 4 over 21? Is that fair? And here, instead of having 1, I'd do 21 over 21 minus 4 over 21. So I have 4 over the square root of 21, all divided by what? 21 minus 4 is 17 over 21. Fair? And then I have a fraction within a fraction, so I'm going to multiply by the reciprocal instead of dividing. And I would get 4 times 21 over 17 times the square root of 21. I need to rationalize that, don't I? So I'd have to multiply by the square root of 21 over the square root of 21. So I would get 4 times 21 square roots of 21 over 17 times 21. Is that fair? Now the reason I didn't multiply that out is because right there those 21s can cancel, can't they? So we get 4 square roots of 21 over 17. Does that make sense to you? Questions? So you might have to go back and look at some of your identities, right? All right, write each trig expression as an algebraic expression in U. So we're doing the same thing here. We think about this. This has to be an angle, doesn't it? All right. So tangent is going to be in quadrants 1 or 4. Everybody agree with that? If U is positive, it's going to be in 1. If U is negative, it's going to be in 4. Do you agree with that statement? Okay. So here, if we look at this in quadrant 1, tangent is opposite over adjacent. So if this is my angle theta, opposite would be here. Adjacent, I can put as 1. Do you agree with that? And then can you find your hypotenuse? Yeah. Your hypotenuse would be 1 squared plus U squared equals some value, C squared or H squared, yes? So then I'd take the square root of this, and this hypotenuse would be the square root of 1 plus U squared. Is that fair? Yeah? Or U squared plus 1, same thing? Okay, so what is sine of this? Sine is opposite over hypotenuse. So U over the square root of, and I'm going to go ahead and write it as U squared plus 1. Does it matter if it's 1 plus U squared or U squared plus 1? Means the same thing, yes? Now what do I need to do?
Rationalize.
Yeah. So I'm going to multiply by the square root of U squared plus 1 over the square root of U squared plus 1. So I get U square roots of U squared plus 1 all over U squared square root. Yeah, U squared plus 1, yes? Questions on that? Okay. Now here what we're looking at is what? Cosine of 2 times whatever this angle is. A? Is that fair? Now because this is in terms of sine, I would use that identity that it deals with sine. So remember with cosine we had 3 different versions of the double angle. One of those versions was 1 minus 2 sine squared of A. Sine is in quadrants 1 and 4. Again, if U was greater than 0, it'd be in 1. If U is less than 0, it'd be in 4, yes. Here, sine is opposite over hypotenuse, so U and 1 here. Now, do I even really need this other side? No, because I'm looking at sine here, right? So 1 minus 2 times sine is just U squared. So I'm just talking about 1 minus 2U squared. Remember, there's other versions of that identity. There was sine or cosine squared minus sine squared. There was one there was one with cosine also, yes? Okay. The optimal angle of elevation theta a shot putter should aim for to throw the greatest distance depends on the velocity v of the throw and the initial height h of the shot. The model for theta that achieves the greatest distance is this right here. Theta equals arc sine of this. Suppose a shot putter can consistently throw a steel ball with a height of 6.6 feet and a velocity of 42 feet per second. At what angle should he throw the ball to maximize the distance? Well, let's look at this. Let's go ahead and plug in what we know. Theta is arc sine or inverse sine, agreed? Same thing? Of the square root of v squared, so 42 squared over 2 times 42 squared plus 64 times h, which was 6.6. So we could probably plug that directly into our calculator just like that is, or you could go ahead and do 42 squared. So inverse sine of the square root of 1,764 over 2 times that is 3,528 plus 64 times 6.6. So then I could add 3528. So what I'm looking at here is inverse sine of the square root of 1,764 divided by 3,950.4. Yes? Now, probably I would say a degree measure is probably more appropriate for this. Here, I think, yeah, I'm in degrees. So I would do inverse sine of the square root of 1,764 divided by 3,950.4. And it gives me approximately 41.9309, and it just keeps going. These are all 2 significant digits, so I would say about 42 degrees. Does that make sense to you? Yes, no, yeah? All right, so remembering where everything, your inverse functions are at. Between negative pi over 2 and positive pi over 2. We know they're all positive here, yes? Here we've got inverse sine. We've got inverse cosecant and tangent. The reason we know tangent is because, remember, tangent had your asymptotes at negative pi over 2 and positive pi over 2, yes? Everybody remember that? In quadrant 2, we have cosine, and then, of course, secant, and then cotangent. So remember, cotangent had asymptotes at 0 and at pi. And that's how we know it's there. And that would be between 0 and pi. Yes? Questions? Okay, your assignment is back there on the board. What you'll notice is it's not due till Wednesday, but you aren't going to have class time tomorrow to work on it. Okay? So you don't have to have it turned in until Wednesday. If you do get it done, go ahead and turn it in. But it's not due until Wednesday. Tomorrow, we are going to